Have you ever wondered how massive systems like Netflix or your university manage tons of data without breaking a sweat? What's the secret sauce behind all that order? Well, it's ERDs, yup, entity relationship diagrams. Welcome back to Ali Ventures, the place where we simplify tech and life. In today's video, we are diving into ERDs, the blueprint behind databases. We will break down what are ERDs, key components like entities, relationships, attributes, and cardinality, different types of each with examples, how to convert real-life problems into a structured ERD, and finally we'll tackle down a hard challenge together. Let's not waste any time and let's build a database designer mindset. What's an ERD? So first thing, what even is an ERD? ERD stands for Entity Relationship Diagram. It's basically a visual map of how data is connected in a system. For example, imagine students' enrollment system. You have got students, courses, and the enrollment that links them together. That's right. There is the heart of an ERD. Things, entities, their properties, and how to connect relationships. Let's break these components down one by one. Entities are a real-world object like a student or a course. Attributes, data is about the object like student's name. Relationship, how entities are linked together like enrollments. But wait, what exactly is an entity? An entity is just a thing, something we want to store data about. But there are two types. A strong entity can stand alone. For example, a student doesn't depend on any other entity to exist. Weak entities, on the other hand, needs another entity to exist. For example, a loan makes no sense without a customer. If a weak entity cannot exist alone, how do we keep track of its property? That's where relationships and foreign keys come in. We'll get to that. Now let's zoom in a bit. Entities have attributes, the characteristics that describe them, but attributes aren't all the same. There are different types of attributes. A simple attribute can't be broken down further. For example, first name, you cannot break it down even further. There are composite attributes. It can be split. For example, full name can be first name, middle name, and last name. Deriven, that can be calculated from other values. For example, age can be calculated from date of birth. We also have single valued attributes, which only can hold one value. For example, a person only can have one date of birth. But multi-valued attributes can have multiple values as possible. For example, one person can have multiple phone numbers. Let's talk about keys. Primary key, it's the one attribute that uniquely identifies a record. For example, student entity, it might be student ID. Foreign keys is a key used to link two entities together. For example, customer has customer ID, loan has loan ID. Loan ID will be an attribute in customers to link each customer to their loan. Without keys, databases would be mixed up and chaos would begin. Relationships, how things connect. A relationship defines two entities that are linked together. It answers the question, how does this thing lead to that thing? Common types of relationships, one-to-one. One student has one locker, one-to-many. One teacher teaches many students, many-to-many. Students enroll in many courses, and each course has many students. But here is a catch. Many-to-many relationships are a trap if they are left unchecked in a database. Why? Because they are hard to manage and can cause data duplication. To fix this, we can introduce associative entity. Cardinality, the numbers behind relationships. Cardinality tells you how many of one entity can or must be associated with other. For example, a student can be enrolled in one or many courses. A course must have at least one teacher. This can be represented using natural language. Each paper must have two reviewers or symbolic notation like crow's foot. Here's a simple trick. When designing ERDs, you draw a problem like a story. Students enroll in courses and teachers teach courses. From this, nouns can be translated to entities, students, courses, teachers. Verbs can be translated into relationships, enrolls, teaches. Adjectives are attributes, like part-time students. Translate that sentence to boxes and lines, boom, you are diagramming already. Notation style. There are different visual styles of ERD, but the most popular one, crow's foot notation. It's named after the little fork symbols used to show many relationships. For example, one line means one, a line with three prongs, crows, means many, a circle means optional, line means mandatory. It's clean, visual, and easy to understand, and we'll use it in the next section. Now let's have a challenge. Let's build a real ERD together. Let's put everything that we have learned into practice. Here's the challenge. You are designing a system for an online bookstore. The system should track customers who can place multiple orders. Each order can contain multiple books, and each book can be a part of multiple orders. Each book has a title, author, a journey, and a price. Each customer has a name, one email, and a date of birth that's used to calculate their age. An order includes an order number, order date, and total amount. You want to keep track of how many copies of each book were ordered in each order. It includes strong and weak entities, many-to-many relationships, composite-driven attributes, cardinality rules, and uses crowfoot notation. You can pause the video here to try your own and then resume to compare it with my answer. Okay, so to solve this question, so we know that we have customers as an entity, so we have customer. Let's increase the size of this. We have orders. We'll drag and drop order here, order, and here we have book. Okay, so this is how we're gonna solve the problem. So I started by creating the entities and writing the attributes, okay, and creating the relationships and writing the cardinalities. So one customer can have zero to many orders, and orders and books are made to many. So how do we solve the many problem? We can add a junction table in order to solve this issue. So we can add a table or an entity called order book, and it will contain order ID as a primary key, book ID, and the quantity. So we already have book ID. Just need to change this to order ID and quantity. Okay, this will be primary foreign key. Okay, yeah, same as here, primary foreign key, and here let me make sure it's a primary key. And as you can notice, our customer is a foreign key here. This is a primary key, and that should be a primary key as well. Yes. Okay, so we just remove the relationship here. We add this here. Okay, and now we need to create the relationships. And the relationships will be many book orders are related to one order. Just do the, no, it's the opposite. Yes, so we have one to one or many, and the same thing here. You can just copy paste it here. So I have one to many as well, and we're done. So this is the answer. Hope you all got it. Let's have a quick recap. ERDs help structure complex data in a visual, manageable way. Understand the key parts, entities, attributes, relationships, cardinality. Use natural language to guide your ERD creation. Normalize your data and avoid many-to-many without associative tables. Choose a clear notation style like crowfoot. Designing a database might seem scary at first, but once you master ERD, it's like building Lego sets for your data. If this video helped you out, smash that like button, subscribe for more tech tips, and drop a comment below. Thank you guys for watching, and see you next time.